Hello students, this is Apu Pankaj. Today let's learn about sets and their representations. Let me first explain you what is a set. In everyday life, we often speak of a collection of objects of a particular kind such as a pack of cards and a crowd of people as you see in the picture. In mathematics also, we come across collections, for example, the set of natural number, points, prime numbers, etc. Let me give you some more examples of set. Let us consider odd natural number less than 10, that is 1, 3, 5, 7 and 9. Similarly, I can consider the rivers of India, for example, Indus river, Brahmaputra river, Ganga river and Godavari river, and also the vowels in English alphabet like A, E, I, O, U. And I can also give you the example of various kinds of triangles. You know what are the kinds of triangles like equilateral triangle, isosceles, scalene, acute, obtuse, right angle triangle, correct? And also you can take the example of prime numbers, right? Prime numbers means which number has only two factors, like 2, 3, 5, 7, and here I am considering the prime factors of 210. Okay, so 210 has four prime factors, 2, 3, 5 and 7. And also I can give you another examples of the solution of equation x square minus 5x plus 6 is equal to 0. Here if you put 2 and 3 in place of x, you will get 0. That means if you substitute 2, this equation's left hand side will become 0. 2 square means 4, 5 into 2 10, 4 minus 10 minus 6 plus 6 is equal to 0. Similarly, if you put 3, both LHS and RHS will be equal, that means 0. 3 square is equal to 9, 5 into 3 is equal to 15, 9 minus 15 is equal to minus 6 plus 6 equal to 0. Okay, so the above examples is well defined collection of objects in the sense that we can definitely decide whether a given particular object belong to the given collection or not, right? For example, we can say that the river Nile does not belong to the collection of the rivers in India. So here I cannot write the name of river Nile, correct? On the other hand, the river Ganga does belong to this collection. Here you can see the river Ganga. So now let us take some other examples also which are not considered as set. Here is one such example, the collection of 10 most talented writers of India. The phrase the collection of 10 most talented writers of India is not considered a set because it lacks a clear and objective definition of what constitutes a talented writer. That means your definition of talented writers might be different from mine, correct? Talent is a subjective concept and there is no universally accepted standard for determining who is talented writer. As such, the phrase 10 most talented writers can be interpreted in different ways by different people, which makes it difficult to determine which writer should be included in the collection and which should not. Okay, so I am writing briefly my reasoning. The reason being this collection is not a well defined. This collection is not well defined because there is no objective way to determine who the 10 most talented writers of India. Let me give you one more example. Okay, consider this example. A team of 11 best cricket batsmen of the world. Is this phrase can be considered as a set? No. Why? Uh, because it lacks a clear and objective definition of what constitutes the best cricket batsman. I mean, the concept of best is subjective, right? And can vary depending on individual preferences, criteria, and perspectives. Your perspectives of best cricket batsman might be different from mine. There is no universally accepted standard or metric for determining who is the 11 best cricket batsmen in the world. This makes it difficult to definitely identify and include specific players in these collections. Furthermore, the phrase a team of 11, this suggests that this collection is limited to 11 players only. But there could be more than 11 cricket batsmen, so could be considered among the best in the world, right? The arbitrary restriction to 11 players further complicates the definition of these collections and makes it inconsistent with the concept of set. So I cannot consider this phrase as a set. So I am writing my reasoning in a brief writing also. This collection is not well defined as there is no objective way to determine who the 11 best cricket batsmen of the world are. Okay, let me give you one last example. Consider the phrase a collection of most dangerous animals of the world. This phrase cannot be considered a set. Why? It is due to the ambiguity and subjectivity inherent in the concept of dangerous here. Dangerous is a subjective term. Determining which animals are the most dangerous in the world, I think, is a complex task that involves various factors, including the animal size, strength, venom, habitat, and behavior also. So these factors can vary greatly among different animal species. So that's what makes it challenging to establish a clear and objective criterion for measuring dangerous, right? Additionally, the notion of dangerous is subjective and can be influenced by individual perspectives. Your experience is different from mine, so you can label danger for different things, and I can label different identity or different behavior as dangerous. Correct. So what one person considers a dangerous animal may not be considered dangerous by another person. So you may consider tiger is a dangerous animal, but I may consider cheetah or a venomous spider is a dangerous animal, right? So our definition of the dangerous animal may not be the same. So this subjectivity makes it difficult to create a universally accepted list of most dangerous animals, right? So if you make a list of most dangerous animals of the world and I make another list of most dangerous animals of the world, our list or the elements of our list may not match. So this phrase cannot be considered as a set. Okay, I am writing my reasoning in a brief format. This collection is not a well defined. This collection is not well defined as there is no objective way to determine who the most dangerous animals of the world. Correct. So now let us know about something. Now let's know about a few more example of sets used particularly in mathematics. So you have to remember them. Always capital N denotes the set of all natural numbers. I can write them like that. Capital N is equal to 1, 2, 3, 4, 5 within curly bracket, and here the 3 dot represents there are infinite number of elements inside the set, and the name of the set is N. And also similarly capital Z denotes the set of all integers, and I can write them like that. Here you know all the negative numbers 0 and positive numbers, that mean natural number included in the set of integers. Similarly capital Q denotes the set of all rational numbers, I mean the number which can be formatted or written in the form of P by Q. All the decimal numbers are also rational number, you know that. So I can write Q is equal to minus 1.8, 0, 0.2, 0.4, 0.6, 0.8, also 1, 1.2, etc. And there are infinite number of numbers, rational numbers are there. Also there are infinite numbers of natural number and integer also. Next, the letter capital R denotes the set of real numbers. R denotes the set of real numbers, and I can write capital R is equal to NZQ. You know that all the natural number, integers and rational number included inside the set of real numbers. Similarly, Z plus denotes the set of positive integers. I can write Z plus is equal to 1, 2, 3, etc. Means integers contains both negative and positive numbers, and Z plus only includes positive integers, like this. Similarly, Q plus includes the set of positive rational number. Okay, so I can write Q plus is equal to all the positive rational number including 0.2. so here are also more, so I have denoted that by 3 dot sign, and they extend to both sides, and there are also infinitely many rational number between two rational number. Okay, so that's the case. You have to remember these signs: N for natural number, Z for integers, Q for rational number, R for real numbers, Z plus for positive integers, and Q plus for positive rational number. Now one is remaining, the set of positive real numbers. I am writing that R plus. R plus denotes the set of positive real numbers, and I can write that R plus is equal to all the positive natural number. All the natural number are positive, so here positive is not necessary. Okay, you also can omit N plus, but I have to write Z plus because there are negative and positive numbers in the set of integers. So Z plus denotes R plus contains only the positive integers, and Q plus indicates that R plus consists only the positive rational number. Okay, that's all. Let's proceed. We usually describe a non-empty set in two ways: the listing method and the property method. Remember one thing: a set which has at least one element is called a non-empty set. Okay, and here listing method can also be called as tabular method or roster method. So different book consider different name for the same method. Similarly, the property method can be called as set builder method. Okay, so now let's discuss about listing method. Remember, in listing method, we list all the members of the set within curly brackets. That means all the elements of the set will be within curly brackets. Let me give one example for clarification. Let us consider the set of all natural numbers that are factors of 10. So, how can I write this set? So, let us, the name of the set is A. So the name of the set is considered or taken in capital letter. So I can write capital A is equal to 1, 2, 5, 10. These are the factors of 10. And you can see here all the members or elements of the set are within curly bracket and separated by commas. But what if the set has too many elements to be able to write them all down? Let us consider one more example. Let's list some of the elements of the set of natural numbers. We have the task to list all the natural numbers within one set. So is it possible to list them all? No, because there are infinitely many natural numbers. So what can I write here? The set of all naturals number. So you know that capital N denote all the natural number. So I can write them like that. Capital N is equal to 1, 2, 3, comma, triple dot. So what is the triple dot sign denote here? In this case, we list some of the elements of the set like 1, 2, 3. Okay. So this is enough to show some pattern which its elements follow. So here what is the example? So what is the example follows? This example follows one pattern. You can see the next element is obtained by adding 1 to the previous one. So if you add 1 to 3, you will get 4. The next element will be 4. So you have just to mention enough elements by which you can know what are the patterns. Okay. Similarly, the set of all even numbers strictly lying between 10 and 100 will be, first I am writing the phrase, the set of all even numbers strictly lying between 10 and 100 is n is equal to, so you can take another name also. I have taken n, but I think it will good if I take another name. Okay, let me take another name. I am cancelling this out and taking another color. Let us take z is also conserved for integers, so I cannot write z here. So let us take b as its name. Okay, so why n is wrong? Because n is already conserved as the set of natural number. Okay, b is equal to 12, 14, 16 dot 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 98. So this much is enough to show you the pattern, which pattern the elements follows. You can see here every number is 2 greater than the previous. So if I want to know the next element of the set, I have to add 2 with 16 and I will get 18. 18 is the next element of this set. Okay, and the last element I have to write the last element. And remember one thing, here the strictly lying between means I have to exclude 10 and 100 itself. Okay, strictly lying between two numbers 10 and 100, that means 10 and 100 are not included. Okay, so I am writing you a definition. This, what is this method? This method of representing set is called the listing method, or you can also say tabular method or roster method. Okay, now let's learn about property method. Let us now learn about the second method of describing a set, that being property method. In this method, we describe a set and its element by a property common to all of them. I mean a property common to all of the element of the set. Let me give you one example. Let us take the example of the set of vowels in the English alphabet. If I first describe the set using the previous method, that means the listing method, I will write like this. Capital V is equal to A, E, I, O, U. You know A, E, I, O, U are the 5 vowels of English alphabet. And if again I will write the same set using property method, I will write like this. Capital V is equal to X such that X is a vowel in English alphabet. I have to mention one more thing. The colon can be replaced using a vertical bar. Some author write vertical bar instead of a colon in the while describing a set using property method. So I can also write like this. X such that this vertical bar is called such that, and the colon is also called such that, but different author write differently. X such that X is a vowel in English alphabet. Now let's consider another example. Consider this set of all natural numbers which are multiple of 5. Okay, this set T can be written in the form. How can we write this? First I will name the set as capital T. In listing method, capital T is equal to 5, 10, 15, and here triple dot denotes that there are infinitely many elements in this set. Okay, these are the these elements are the multiple of 5, means you will find these in table of 5 and beyond, 5, 10, 15, 20 like this. Okay, now if I will write the same set using property method, I will write this. Capital T is equal to X such that X belong to N, means X is a natural number and X is a multiple of 5. Okay, so yeah, this set also can be written in another form, in a shorter form, like this. T is equal to X such that X is equal to 5n and N belongs to capital N. So here I have written a shorter form. of the same set, and these two denotes the same set, describe the same set. Okay, so you know how can we write the same set using both listing method and property method. This method of describing the set is called the property method or set builder method. In some book you will also find this method of describing a set is called set builder method, and I just described how you can write a set using property method or set builder method. You just have to write in this format. You have to write the common property of all of the element of the set. Okay, now let's proceed. Now consider the following set. Here I have taken an example of a finite set, and this set denotes the coin collection of the National Museum, Delhi. There are 1, 2, 3, 4, 5, 6 elements in this set, and now if I will ask which element belongs to the set and which element does not belong to the set. Okay, let me ask you one question. The question is this object belongs to the set C, the set of National Museum, Delhi? So let us rethink again. Here are the set of National Museum, Delhi, and you would not find this object in this set. Okay, so I will say this object does not belong to the set C, and there is a symbol for does not belong to, like this object does not belongs to, and this symbol can be denote does not belong to. Okay, so writing all the elements, we can write the name of the set. Here the name of the set is C, and now I am going to ask you another question. Is this object belong to the set? So if you analyze, you will find this object belongs to the set of National Museum of Delhi. Here is the element. Okay, so I will denote by another symbol like this. This symbol denotes that this object belongs to this set. Okay, instead of writing all the elements, I can also denote like this, also write the name of the set C. So here this object belongs to the set C. Okay, now let's proceed. Okay, now consider the following sets. A is equal to 1, 2, 3, 3, B is equal to 1, 2, 3, C is equal to 2, 1, 3. Are these equal? I mean, A, B, C contains different elements, like? No, they contain the same elements but in different way. Here A contains same 1, 2, 3, B also contains 1, 2, 3, C contains 1, 2, 3, but in different order and different number of times. Remember, if I will repeat one element of set, the set doesn't change. Means here A, B and C are equal. Yes, these are equal. Here A, B, C are equal. Now I am going to ask you another question. Now, are these equal? Here both the set are described in the property method, right? And in the first set, the elements belongs to the set of natural number, and the second set B, the elements are in the set of real number, right? And both of the set, the element of the set contains the same property, means their square is 9. So if in the first set A the elements belongs to the natural number, okay, then only 3 will be the element of this set. So I can write like this. Here A can be written 3 in the listing method, and B can be written as -3 and 3 in listing method. So here minus 3 is included because negative numbers are also included in the set of real number, correct? So here as you can see, the sets are not equal because the elements belongs to different set. Set A belongs to the set of natural number and set B belongs to the set of real numbers. So here I have written A is not equal to B. These led us to the following remarks. Remark 1 is, while listing the elements in a set, we do not gain anything by repeating them. Therefore, the convention is that we do not repeat the elements in a set. I am giving one example. Here there are two examples actually. The first one is 1 2 3 3 and this is equal to 1 2 3 1 comma 2 comma 3, and uh, the convention is we do not repeat the elements in a set. So this is the correct way of writing the set and this is the wrong way because we have written 3 two times, we have repeated one element two times. Similarly here this is the convention of writing the set and this is not correct because here we have repeated some element more than once. Like here A is repeated twice, B is repeated thrice, okay. And now let's proceed to the remark number 2. Remark 2 is, changing the order in which the elements are listed in a set does not alter the set. Here is an example: 1 2 3 2 3 1 3 1 2. These three are correct and these three are equal. 1 2 3 is equal to 2 3 1 is equal to 3 1 2. Now let's proceed to remark number 3. Remark 3 is, there can be several properties that define the same set. Let me give you one example. Here 2 can be represented in two ways and both the ways are correct. In the first way I have denoted it as x such that 3x minus 1 is equal to 5, and the solution to this equation is can be only 2. Means only if I will substitute x by 2 I will get LHS equal to RHS, and any other value of x will not satisfy the equation. Here I am explaining you how. If I will put 3, this will become 3 into 2 is equal to 6, 6 minus 1 is equal to 5. Here LHS equal to RHS for x is equal to 2, correct? And the same set can also be denoted or described by this x such that x is an even prime number. You know that the only even prime number is 2, correct? So both the way is correct to describe the same set, okay. Now let me give you one similar example. The set of all natural numbers less than 4 can be described as in these three ways: a is equal to 1 2 3 3, b is equal to 1 2 3, and c is equal to 2 1 3. So these three describes the same set, okay. So that's all for today's class.